Okay, I think we've given everybody time to join here after 1 o'clock. So I want to welcome everybody to our webinar about delivering beyond gigabit performance with current GPON infrastructure. We are two hosts here today on the webinar. It's our CTO Kim that I will leave a bit of time in a minute for introducing himself. And my name is Erik Petersen. I'm the Chief Commercial Officer in Icotera. Icotera, we'll do a short introduction in terms of who we are. We are delivering products for the FTTH industry, focusing on better connected living. We are focusing, which is not something we're going to talk much about today, but we're focusing on delivering high-end, best-in-class Wi-Fi solutions and real-time monitoring of networks and Wi-Fi. We are the leading FTTH provider in the Nordics, and we've been in operation for 16 years. I myself have worked here for the last 3 years, and we are, I would say, experiencing a very nice growth phase these days. So business is good even in these very disturbed and difficult times around COVID. So I think that's something everybody speaks about when they speak about business. But we see that the demand for good fiber infrastructure, fast internet connections is actually increasing in these times. And I hope that you're experiencing that as well. So maybe over to you, Kim, for a short introduction.
Yeah, thank you so much, Erik. I hope volume and everything is okay from our side, because as Erik said, it is difficult times. We're all working from home. Erik and I are no exception, so welcome to our home offices. My name is Kim Jorgensen. I'm the CTO, and I'm also the founder of Icotera. So I've been with Icotera for these 16 years, and always with a technical focus as CTO. I drive the innovations department at Icotera that consists of product development mostly, but also customer support, integrations, and cases like that. Very close cooperation with our development, with our testing, with our sales, and with our marketing. So a central technical function in the company. And Icotera obviously is focused on delivering FTTH products, but in many recent years actually, also Wi-Fi solutions of high-speed Wi-Fi 6, etc. solutions. So very much looking forward to talk to you about GPON and extending the infrastructure today.
All right. So if you have questions on the way, you can ask them on the console. We'll probably choose, unless there is something that needs to be clarified on the individual chart, we'll take them at the end. So we have a section for questions and answers at the end, but you're welcome to send in your questions right away. You might even get an online response on it, but we'll in most cases actually read them out and share them with everybody. So basically the topics we're going to go through today is a little bit about the technology behind what we call beyond gigabit on GPON infrastructure. Then we'll turn to the market and talk a little bit about how is the technology used and what offerings exist and why is this relevant. So we'll talk a little bit about what do we see in markets and how do you as a network and an ISP differentiate in terms of delivering those speeds that the market is requiring or that you from a marketing perspective want to offer. And then we'll go and talk specifically on the product and explain what it is we can deliver to you. And then basically at the end, talk a little bit about what other features is coming in the product and how do we see this product actually being a good investment for you in terms of the CapEx and the OpEx investments, but also in the installation costs and you could say the truck rolls needed on a certain product. So those are the things we're going to go through. We'll try to end around somewhere between half and 40 minutes past 1 and give you the opportunity to come with your questions so we can clarify even deeper. All right, over to you, Kim.
Thank you. So before looking deeply into how we extend GPON infrastructure, let's first look at what options are available. Today, we have a Gigabit standard IEEE defined, very easy to integrate with, but limited to a Gigabit, 1 gig point-to-point. I would say for point-to-point infrastructures, the by far most dominant technology. GPON, ITU-T defined standard infrastructure, also, at least in the recent years, well standardized, and interoperability between different vendors seems to be working, at least from the Icotera perspective, quite okay. Limited to 2.5 gig downstream, and even though the standard does offer support for going symmetric, so 2.5 gig down, 2.5 gig up, we see that the typical implementation is 2.5 gig down and 1.25 up. So that's why we put this here in the presentation. And mind you, this is before the overhead of management layers, etc. So one should expect at least a 10% degradation there. XGS-PON is the, can we call it an upgrade of GPON? It adds 10 gigabit, the X, and adds symmetric. So 10 gig downstream. It's still shared bandwidth. It's still bandwidth that is shared between a number of customers, depending on the services being offered, but typically limit to a maximum of 128, both because of practical reasons, but also because of bandwidth. The other one is the IEEE standard in GPON 2. That is, we could say, an extension or an upgrade of EPON that allows for 10 gig as well, but also offers support for multiple wavelengths, having multiple wavelengths that are each carrying a 10 gig signal to the end users. And last but not least, a technology we see coming more and more to especially the Nordic market as a 10 gig point-to-point infrastructure. So just a simple upgrade of the existing 1 gig to 10 gig. So same basic standard, very easy to do interoperability with, and reasonably cost effective also when deploying, at least from the CPE perspective. So looking at the technology that are deployed today, that are mostly 1 gig point-to-point and GPON, GPON seems to be the winner because it offers 2.5 gig downstream. But end user equipment is still limited to a gigabit, and we're seeing the offerings also taking that limitation into consideration. On the 2.5 gig thought, 2.5 gig or 2.5 G base 10, as it's dubbed, is getting more and more traction these days. And it's our expectation that within a number of years, 1 to 3 years, we'll see this as the de facto standard in laptops and computers. The laptops, mind you, that still has a physical Ethernet interface. If you take the next slide, then looking at the technology that is available, mind you, Gigabit and GPON offering 1 gig or 2.5 gig, it's surprising to see that, and this is the results from speedtest.net from August this year, it's kind of surprising to see that countries that boast themselves of having a very strong fiber footprint still has maximum peak test in an average of roughly 150 megabit. We also know that when speaking with the service providers, they usually see an average peak consumption from their users, an average one of around 10 megabit per second. We know that the most bandwidth hungry of the typical services, the Netflix Ultra HD, consumes, according to Netflix himself, a peak of maximum 2.5 megabit per second. And we also know that most distribution POPs, we call them that, distribution areas, distribution houses, typically have from 500 to 1,000 customers and are typically connected with 10 gig infrastructure. So of course there can be POPs that have more customers, 3, 4, 5,000 is not so uncommon, but there's also POPs, especially in the less dense populated countries, that have significantly less customers. Common for most of them is a 10 gig access infrastructure. That can be redundant, but that's typically the case. So looking at the speed test that is being offered and the landscape of internet services, etc., then and looking at the average consumption, the obvious question would be, why are we chasing 10 gig last mile access infrastructure? And the simple answer to that is marketing. try to take it back. Yeah.
Yeah, and but just turning a little bit, and this is, I'm fully aware this is not a full market analysis, but it's a couple of examples of what you see in various markets and what's being offered in various markets. And if I start a little bit with the Danish market, just as 3 examples, you can see that the primary offering, the competitive, where you could say the challengers are trying to push, is actually offering a gigabit, either full gigabit upstream downstream, or 1100, or which is not symmetrical, but at very aggressive prices. But we also see in some markets, and I've just taken 3 examples here, where fiber is being offered in such a way that they are actually having a commercial offer of 10 gig. And then you can ask yourself, do I have a PC? Do I have a wireless LAN that can support that? But it still becomes the challenge. So we're starting to see the marketing offers being more speed. But obviously, as 10G and XGS-PON is a more expensive technology, both on the central and decentral front, it means that you need to buy or invest more in those customers to be able to offer that. What's interesting is, if you turn to the ComHem in the right-hand corner of the picture here, and this is not a fiber offering, actually it's a DOCSIS offering, they're trying to take the mainstream offer as a 600 megabit, and then having a 1.2 gigabit, kind of to challenge everybody that offers a gigabit offering. And then they're pricing that. I can say the 25 euros is an introduction offer of the 600 megabit, but it's still what you're going to pay the first year. But then they try to get more money out of you could say, a speed that is bigger than what is the general commercial offer. So combined with the fact that we start to see routers and PCs coming with 2.5 gig, maybe the time to be able to offer something that's faster than a gigabit is there. And on that basis, we actually believe that this leveraging the existing infrastructure with a solution that can provide you more than a gigabit, maybe the timing is right. And then you could say, why not go to 10 gig immediately and go to XGS-PON? Absolutely, but there's a price tag on that. The interesting thing could be, if we could offer, you could say, at the same price as we're offering or buying CPEs at today, offer a faster speed and the capability of actually meeting the needs from the future routers, which might have a 2.5 gig port in them. So that's the whole thinking and the reason that we believe that there is a commercial possibility of going out in the market with something that goes beyond the gigabit.
Thank you, Eric. So as you said, the question becomes, what if we had 2.5 gig end-to-end throughput? All the way from the OLT, shared infrastructure, the yellow part of the slides here, shared infrastructure to a number of CPEs, but some of these CPEs being able to offer more than a gigabit downstream. That's the chance for the marketing department, for the service providers, to offer more than the gigabit, and at least offer gigabit with a kind of service guarantee where the gigabit can actually be achieved. Mind you, of course, the end user equipment needs to be able to offer that. But what we also see with the recent Wi-Fi standards is that they are able to far exceed that of a gigabit, and typically come with a 2.5 gig connection to the network because of that high bandwidth. So if you try to take the next slide, the answer to those questions is the i5900. And this is a product that Icotera is in the process of launching now, bringing to the market now, where we expect the first rollout to happen already this year. It's called 5900. It's a GPON gateway, so familiar for all of you, multi-vendor OLT, as is typical for Icotera GPON products, with a 20-kilometer range. It comes with an optional CATV functionality that, depending on the market, might be interesting or might not be, supporting the specific filter solutions. It has a standard, I think we can say, sorry, a standard solution of 4 gigabit network ports for your set-top boxes, for your computers, etc. And then the unique feature is one 2.5 gig network port that, besides the 2.5 gig, also supports 100 megabit and gigabit. So this is the interface that allows direct communication from the GPON uplink to the customer and customer devices with 2.5 gig infrastructure. So of course the ASICs and the network packet accelerator supports up to 2.5 gig forwarding of packets, both in layer 2 and in layer 3, IPv6, multicast, with firewall, without firewall, DS Lite, 6RD, etc., etc., etc. It has an optional 2 port VoIP. It has MSDW. We'll come back to that later, exactly what that is and how that works. And it's with the standard Icotera software package. But as something special, it also has a easy mesh controller. And for those of you that have read all these numbers, you'll notice that all these bullets, you'll see that it does not have Wi-Fi, that it is a router at the same time. It supports routing functionality. And this is what we mean with MSDW. If you take the next slide, then one specific scenario where we can use this product is for the wholesales. So it's a wholesales design solution. So what it means that it supports GPON, but it supports multiple service providers on the same access equipment on the same end user installed CPs for multiple service providers. So that is the traditional service aggregation. We all know that. We've been supporting that ever since the first products with VLANs and Q&Q, etc. But it, and especially important for a shared CP, it also supports very advanced quality of service mechanisms and the use of rate limiting, at least for the upstream part. For GPON network, that's the essential for the CP, to support the service segregation, and not just service providers, but also the services within the service provider. So that talks for a hierarchical, very complex quality of service mechanism. Concurrent router support, so it means that some users can be terminated with a router, some can be running in layer 2. It supports source-based MAC routing, which is a unique functionality for Icotera products, where we allow specific equipment to be routed out of a certain VLAN or Q&Q VLAN, CVLAN, and so on. CWMP and TR69 as the de facto standard management protocol. For this means that the network provider can control this device and allow service providers to deliver the services based on the configuration through the ACS exactly as you wish for. It has one 2.5 gig port, so one service provider can offer the very, very high speed services, whereas 2 other service providers, or 3 or 4, depending on the requirement, can offer the services on the other ports. And then the part about Wi-Fi. So by removing Wi-Fi, we are extending the lifetime of the product. And Eric, I think this was your slide.
Yeah, exactly.
Yeah.
I was almost saying, you're going to do my part
is that
now.
yours, or is that? Yeah.
So
it's because I wrote it.
So I would say this is based upon, I would say, the experience that we've had over the years, that we've been delivering one-box solutions to many of our customers over the past many years. But what we also learned is that what actually happens is that the device that you terminates the fiber, there are 2 things. First of all, it sits on the wall for a long time. We have customers running IGB 2000. I'm not even sure when we delivered that, but that's close to 10 years ago. And we have customers that still have them on the wall. They're rolling and they're functioning very, very good. So the fiber termination device actually stays very long in the home. So that's the first important point. And the other important point is, unfortunately, the place where people, or where the fiber is terminated, is not always the best place for a Wi-Fi signal. You want to have the Wi-Fi, the router, or at least the extender, as central as possible to get the best distribution of your Wi-Fi signal. So basically, the fact that Wi-Fi is changing every 3 to 4 years, and that the fiber device sits there for a long time, not putting the Wi-Fi into the box is actually could be a benefit in terms of not spending too much capex and not having to replace, basically having installation costs or truck rolls in replacing the units in the home. So we are doing that by separating these two, it gives the possibility of placing the wireless in a much more strategic place for good coverage in the home. So the idea here is to extend and actually recognize the fact that a fiber device will sit on the wall for a long time and actually work for a long time, but you still need to upgrade the Wi-Fi. And as that is a fact, why not separate the two? And that was the idea behind behind separating or taking the Wi-Fi away from the device. Now, when we talk about this multi-service gateway, which is eventually the setup, the traditional way of doing it is that you buy a device, including, so you pay for the Wi-Fi. That's the rest, the one-box solution that is called the existing setup. But basically, that investment is then, in quotes, lost. You turn that off at a point of time, and add a router, or you replace the fiber device because you want to have a new Wi-Fi installed instead of what you already set up. Whereas the future setup with the 5900, with the multi-service gateway, is that you, from the start, have separated it, but that it also have this easy mesh controlling capabilities. And I'll come back to what that basically means for you. So it's a Wi-Fi enabled device without having Wi-Fi in it. So, and at the same time, you have the possibility of ensuring that if you deliver the full package, that you actually can add the, that you actually can place the access point, which is cheaper than a router because it doesn't need the routing capabilities. You can place that much more strategically. And you can then extend, of course, in the same way as you can today with our products, but you can then extend with additional access points, wired or wirelessly. So the whole idea here is the separation, getting the multi-service gateway, but also getting the easy mesh controlling inside the unit. And if you look at it, and just to put it in a perspective of a 12-year period, where the fiber device will be sitting on the wall, eventually, if you want to replace the one-box solution every year or every 3 years because you get new Wi-Fi, that actually adds to the cost. You could even say, well, it's better that I just have a simple fiber termination and then I put a router on top of that. But what you're missing there is that you pay for the router every time you send a new router to the customer. So from a long-term economical perspective, investing in a multi-service gateway from the start is maybe a little bit more expensive than a one-box because you get two power supplies and you maybe need to do some cabling in the home from the start. But after that, it's easy to replace access points. And since you're only replacing the wireless part here, actually the long-term cost is the lowest on the multi-service gateway solution. So overall, you will save money, and then you can discuss if you're going to replace Wi-Fi every 3 years or 4 years, and I know that changes the picture, but it doesn't change the overall perspective that this is actually long-term the most cost-efficient way of moving forward. Now, I was speaking a little bit about this easy mesh, and the idea behind easy mesh and the easy mesh controller is actually when you have the router in centrally and you have support for easy mesh, it basically means that you are vendor independent on the APs. So you can go out in the market and select any easy mesh compatible device, and that will be controlled from the router. And what does that mean? What does it mean controlled? What it basically means is you could in theory have a Nokia AP combined with a Google AP and an Icotera AP controlled by the same easy mesh controller. And when you move around with your mobile phone, or when your TV sits in a certain area where it's best connected to one AP, the controller will evaluate which access point to use for distribution of the Wi-Fi signal. So that's a standard. So replacing from a Wi-Fi 5 to a Wi-Fi 6, in one room would immediately give an effect, and the control of where the optimal connection sits is always done upon a certain set of standards, so that you know that you can be executing the best possible coverage of the home. So you're taking the vendor lock-in away here, and being open for people to choose, you could say, various access points, depending on design, how much power they want in terms of, do they want to have a device that is cheap with 2 antennas, or do they want to have a well-performing device with 5 or 8 antennas? That is something you can leave up to, you could say, your marketing department to offer that and give the best possible coverage, but you are not locked to a certain product or a certain vendor providing those APs. I know that speaks against us. Of course, we would love you to be locked in on Icotera, but this is the way the world is moving. But what is important is that the roaming and the steering is the base for good Wi-Fi performance. And the multi-service gateway offers that easy mesh controller agent, you could say. Okay. I think I saw some pop-ups with some questions and so forth,
yeah.
Kim. I don't know if
yes,
you...
Yeah, exactly. Let me try to read it for you. So it says here, the prices are very low. So according to current 1 gigabit connection, you pay at least 80 to 99 euro. So where are we in 2 years with pricing? So in regards to pricing, where will we be on a gigabit connection in a couple of years from now? How do you look at that, Eric?
Well, I think that in terms of the GPON technology, the GPON technology will exist for a long period of time. And from a pricing perspective, I think there's going to be some regulation in the market on the GPON technology, but that will probably be the entry point. The XGS-PON pricing will be still be today. XGS-PON pricing on the central and decentral side is probably in the range of 40 to 50% above what you have on GPON, and that will of course close the gap. So over time, XGS-PON will probably become the standard commercial offer. But what is great about GPON and XGS-PON is that it can coexist on the same network. So it basically gives you the possibility of reusing units in the network in a smart way, and then slowly transitioning to XGS-PON centrally and decentrally. So I don't know if that answers the question as such.
If I would build on it, I would say that the cost of supplying infrastructure is of course one of the defining factors for the sales price of that. And we've seen that cost of infrastructure equipment has gone down over the last few years, significantly actually. And this is how it is. A new technology is introduced, and the existing one is optimized, goes in high volume, etc., and prices goes down on the equipment. So that's one factor. The other factor, of course, is the running cost, which has probably not changed so much over the last few years. So I think, at least from my perspective, I would expect to see that the cost of the premium services would keep more or less their level. If nothing is added, nothing is removed, but the speed increased, then I would expect to see more or less the same level. I do not expect that internet, high-speed premium offering internet is going to get significantly cheaper than what it is now. There's one more question. It goes in the line of, does 5900 allow Wi-Fi AX? And that's a technical question. So if you don't mind, Eric, I will. And that question was asked before we went into the detailed talk about exactly how the MSGW and removing Wi-Fi extends lifetime, etc. Removing Wi-Fi extends lifetime, etc. So here the obvious point is the 5900 does not have Wi-Fi. You supply Wi-Fi with it via an access point that could be an Icotera access point. We have a few models that can be used, or taking a third-party easy mesh compatible access point and connecting it to the device.
Okay. Okay. Any other questions? You can actually ask both in the QA session and in the chat session. So
We had one point here saying that I see more a move to XGS-PON.
Mm-hmm.
And do you want to take that, Eric, or should I?
Yeah, you're welcome to do that, because or we can fill in on it.
Okay.
As mentioned when I was talking around the pricing, I actually see definitely customers move to XGS-PON, and that gives a possibility of differentiating up to something like 5 gig or 8 gig or 10, maybe not 10 gig because that's the limit, but close to that limit. But again, from an investment point of view, there will be more money attached to putting up a full XGS-PON setup. So here the coexistence is very good, and we see this as a good step in between without having to invest in new central infrastructure, but adding, and then maybe even adding XGS-PON to those customers, maybe business customers from the start, that needs more than 1.5, 2 gig, but really has a real need for the higher speed. But I don't know, Kim, if you want to add anything to that.
Yeah, I can try. I mean, it also depends locally on the market, and what was added as a comment later on for the question was in Switzerland. So we're definitely seeing, that was also part of your slide, Eric, that there are local disruptors in the market that are offering high speed, and as a consequence, we see many moving together with that. That comes with a high cost to extend infrastructure like that, and it's definitely not a trend we see over all of Europe. What we're seeing is that if the infrastructure is able to deliver the services that should be delivered at reasonable speeds, and there's no disruptors that are destroying that, then that infrastructure tends to be in place. And if there's not enough aggregated bandwidth on the links, we rather see a split of the GPONs, for example, and gigabit point-to-point just staying there with that limitation. So this is it. It's also true that when a new operator starts deploying, then going for the latest infrastructure usually makes good sense. But there is a very, very large installed base of various networks here that have infrastructure in place, making it very, very difficult just to upgrade, replace customer equipment, etc., and bring everything up to 10 gig, which is often the case. Because the points of presence, the places where access equipment is installed, is limited in space. It's difficult to squeeze in 2 parallel infrastructures, even though it's possible on the fibers, but physically to have that kind of equipment in place is in a large deployment often quite difficult. If we move on to the next question, there was a question, I'll answer that quickly. When Wi-Fi is removed from 5900, is there support for power over Ethernet for easier connection of APs? And this was a design decision for the 5900 not to do that, because we see that for the commercially available access points, for residential deployment, PoE is not de facto. It's not a standard. It's very, very rare. And it does come with a cost up that is sometimes difficult to justify. How many PoE ports would there be, etc. So it's true that it makes for a neat, very nice installation, but it's not part of the 5900 scope, nor is it part of our access point scope. Another question I can answer fast: is 5900 compatible with the 5850 tray, or does it involve any changes as when going from 5800 to 5850? So the 5800 and 5850 are both compatible with the 5900. We use the same FTU, so you can easily just slide off the existing 58 or 5850 and put on the 5900 instead. It's an exercise that we have actually tested that normal end users are able to do in virtually all the cases. It's a very, very simple exercise. We have another question here. Does all the layer 2 quality of service mechanisms implemented in the 5801 also work on the 5900, especially for the 2.5 gig port? And for that, the answer for that question is yes. We support all the same layer 2 quality of service mechanisms, also for that high-speed port. And there's another question here saying, when can we have a sample? And that is a very good question. So we are testing to the in the end of the year, in the last quarter that just started now. So feel free to contact me or to contact Eric for testing. We will set it up, and it should be roughly in a month or two from now, we should be able to conduct proper testing before Christmas.
And the question, we have a question around the 5850, if it's end of line for 5850. We don't see it that way. We still see customers that are having rollouts on 5850s. So we don't have an end of line for that. I would say over time, at some point of time, Wi-Fi 5 will stop being what people want to offer. And therefore, that would be the end of the 5850. But we still see some, I would say, justification for Wi-Fi 5. And we still have customer demands and rollouts on 5850. So there's not announced an end of life for 5850. 5850 and 5900 will coexist for a period of time. I think there was a question around the layer 2 quality of service mechanisms.
That one was answered.
Okay.
It says here, there's a question, is or will your MSTW be certified for Nokia ISAM and Huawei 5800? So the MSTW functionality and the termination of the router functionality, etc., of course, is supported in conjunction with the Nokia ISAM and the Huawei 5800 platform. That will work, yes. There could be specific integration, there could be vendor proprietary management that is not part of the scope of our implementation, because we're offering the control and the management of that service through the TR69 interface. So that's something to be aware of, but that should not be a limitation in your rollout. There is a question about the pricing of the 5900. For here, you need to contact Eric. He will be able to support you with that.
Yeah. Okay.
How come CATV is still a thing? Is it Nordics only? I think that's a good question to end this webinar with, Eric.
Yeah. And I would actually say it's not a Nordic thing only. We're actually in process of developing a new device for a customer not in the Nordics with CATV. I would say from a marketing perspective, as a service provider or as a network provider, there could be benefits of providing CATV. First of all, people like to have their TVs connected with the current cable infrastructure. So that's one element. There are other places where those that actually place the units, so the ONTs in the homes, have a possibility of an additional income from the CATV signal. And so from a investment point of view, investing in the infrastructure into the home, there's a marketing perspective and a possibility of making money in that. I would say I think that Kim and I had some presentations a year, 1.5 years ago, where we were questioning how long is this going to take? And now we have specific cases for markets where we are developing new products with CATV. So I don't think it's going to go away. Maybe in 5 years it will be different, but we still see demand, also demand for specific products, bespoke products that include CATV. But there are many markets that have gone completely to set-top boxes or over-the-top TV signals, and definitely with the speeds we're talking about here, recognize that works very well. But the demand is still there for CATV. Okay. I think that's a good maybe conclusion on the webinar for now. I appreciate everybody joining in here and the many interesting questions. Thanks for being very interactive. We appreciate that. If you have any additional questions, you're welcome to contact either me or Kim or one of the local reps. We would also motivate you to sign up for some of the other webinars we have on the way. We try to keep this as an ongoing exercise to share at least our perspective on what's happening. And especially Wi-Fi, we believe a lot of good things are coming out, and so that we can share with you. But you can go to our webpage and go on the webinars and sign up for that. So thank you so much for participating today. There will be a survey at the end. If you would like to give feedback there, that would be great for us. I think that's it for today. Thank you everybody for joining in. Bye.
Thank you so much. Have a good day.